Hey, Algebra 2 honor students, this is going to be the start of Unit 7. We are going to be talking about a lot of quadratics and quadratic properties in Unit 7. Today, specifically, a lot of algebra surrounding how do we find the vertex of a quadratic and how do we find the roots. The vertex is going to be that turning point. That turning point could be a max or a min. Quadratics are in the form of a parabola. We've done this a little bit already. If we think back to some of the things that we've done with functions and function transformations, we've had some practice with this, but certainly need to extend our discussion about finding vertex points and then finding roots. We're going to start by talking about ways to determine roots algebraically. And there are three ways to do that. And the roots, when I talk about them, they're the x-intercepts. Sometimes they're called zeros. Sometimes they're called solutions. They're called a lot of different things. But first and foremost, the way we find them is when you set a quadratic equal to 0, maybe we can just factor it. And that's the best way to go about it if it is factorable. Another method that you can use is CTS, which you should be familiar with because we've done it a little bit so far. Complete the square. Complete the square is a good way to be able to get x alone using that technique. And then last but not least, we haven't used this yet this year, but you did learn it in Algebra 1 about good old quadratic formula. And we may need to recap that through song. I don't know. Did you ever have a teacher sing it to you? Well, get ready for it. Here we go. Ready? It goes to the tune Pop Goes the Weasel, if you know it. Dun, 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 dun. All right, here we go. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a good thing I really warmed up my voice before that one there. So we definitely have to know quadratic formula. Super important to finding roots when it's not factorable, okay? If it is factorable, I can still use this, but factoring is always the easiest if it's available to us. So let's jump right into an example where we're going to find the roots of f of x equals x squared minus 2x minus 3. So first and foremost, I'm going to try and factor this. I'm going to try and use my method A up there. And when we're finding roots, you set the equation equal to 0. And is it factorable? Are there things that multiply to -3 and add to -2? Well, there sure are. So that is the easiest way to find the roots, if possible. X equals 3 and x equals -1. And again, the connection here is when I find those roots, you don't have to necessarily write this currently unless it said use coordinate form. But that means that the x-intercepts are at 3, 0, and then -1, 0. Like I was mentioning, even when something is factorable, these other methods always work. So let's see what completing the square would look like for something like this. When I complete the square, if you remember the process, I'm going to add the c value to the other side. So when I set that to 0, I would get x squared minus 2x and then add the 3 over. After doing that, remember the process is take the middle number, divide by 2, and then square it. So -2 divided by 2 is -1. Squared is +1. So you're going to add 1 to both sides to keep this balanced. So the left side becomes x minus 1 squared when we factor. 3 plus 1 is 4. And then square root, square root. Don't forget, when you take the square root of both sides, 2 right, plus or minus, well, square root of 4 is 2. So if I add that 1 over, we get x equals 1 plus or minus 2, and 1 plus 2 is the solution of 3. 1 minus 2 is that solution, -1. So we're going to get the same two solutions from factoring. Perfect. That's what we would hope for. So completing the square, when it's not factorable, this wasn't too bad of a process. There might be some other things to look out for with completing the square, though, algebraically. And then finally, for quadratic formula, if I go back to x squared minus 2x minus 3 equals 0, we'll confirm that we can get these same solutions as well. When we're talking about a, b, and c in quadratic formula, they're the coefficients of x squared. There's my a. B is the coefficient of x, and then c is the constant. So it's going to be x equals -e, which is +2. Plus or minus the square root of b squared minus 4ac So plug those numbers in, right? B squared minus 4 times A times C all over 2A. Okay. So we plugged all that information in. Now we want to simplify the part that's under the radicals, the area that students tend to make the most mistakes with, if any. Negative 2 squared is 4. I like to grab the negative 4 with, or the negative sign with the 4 when I multiply these three numbers together. Negative 4 times 1 times negative 3 is a positive 12. So remember 4 and then plus that 12 is 16 all over 2. So this is 2 plus or minus 4 over 2. And if I separate that with the plus and minus, 2 plus 4 over 2, well, hey, 6 over 2 is 3. And on the other hand, 2 minus 4 divided by 2 would be negative 2 on top divided by 2, which is negative 1. Same exact roots as all these other techniques. So it's good to be able to be very fluent and confident with factoring when it is factorable. But then whether or not it's factorable, definitely using complete the square and quadratic formula, great and very, very important skills from in this course and beyond. Okay. So let's try another one for practice. If we do x squared minus 6x minus 10 equals 0. If I want to find the roots, I won't make us do all three techniques this time. So let's start with factoring. Is there anything that multiplies to negative 10 but adds to negative 6? Oh, 1 and 10, 2 and 5. Nope, not liking any of those combos to add to negative 6. So it's not factorable. So out of complete the square or quadratic formula, you can use either of those techniques to find the roots. I'm going to choose CTS for this one for a few reasons. If there's no lead coefficient, I like completing the square. If there was a lead coefficient like a 2x squared or 3x squared, you have to divide that out before you CTS. So we'll get into that later. I also like completing the square when b is even, because what do we have to do? We have to take b divided by 2 and then square it. So I kind of like this example for completing the square. So I'm going to start by adding the 10 to the other side, move that c value over. Then take the b divided by 2 and square it. So negative 6 divided by 2 squared would be negative 3 squared, which is 9. You can probably do a lot of that in your head. You don't have to necessarily write it down off to the side unless it helps to do so. So with that 9, you add it to both sides. X squared minus 6x plus 9 factors into x minus 3 squared. And then 10 plus 9 is 19. Comparing it to what we did earlier, once we got that quantity squared, then I took the square root of both sides to continue solving for x. So x minus 3 equals, don't forget, plus or minus the square root of 19. And then add the 3 over to get x equals 3 plus or minus radical 19. So there are technically two roots here, right? It's one of them is 3 plus radical 19 and the other is 3 minus radical 19. They're not the nicest values ever. We can figure out what their decimal approximations are. But whatever they are approximately, these are the two places where we cross the x-axis. At 3 plus and at 3 minus the square root of 19. Okay, moving on, I want to talk about in the next example, finding not only the roots, but also find the vertex. So for f of x equals 4x squared minus 4x minus 11, we're going to do two things. We're going to find the vertex and the roots. Okay, so 4x squared minus 4x minus 11, how do we find the vertex? Well, what I'll tell you is finding the vertex algebraically involves something that we already know, which is complete the square. Have to do that to find the vertex algebraically. The roots, we have some options, right? Maybe it's factorable, maybe it's quad formula, or if I've already done CTS for part A, maybe I want to use that in part B. But here's the deal. To complete the square for something like this, we've had practice like it in prior units. But I am still going to start by adding the C term to the other side. So I'm going to add the 11 to this side. Notice how, and this is super critical, leave f of x in the equation. Don't set this to 0. You really don't want to plug in 0 unless you're finding roots. And it doesn't seem like a big deal, but I'll show you in the end where we would lose some things if we plug in a 0 right now. leave it as f of x equals, okay? So go ahead and in this next step, before you complete the square, you have to divide by 4. Can't complete the square unless the coefficient of x squared is a 1. So this becomes f of x plus 11 all over 4. Don't worry about that too much yet. We'll leave it as is. And now on this side, I have x squared minus 1x when I divide both of those by 4. Okay, so it's nice that 4 went into these two terms evenly. But now I have to take the b value of -1, divide it by 2, and square it. That's how we complete the square for what's left. So -1/2 squared, well, since 2 doesn't go in evenly, leave it as a fraction -1/2. And when you square -1/2, you get a 4th. Square the top, square the bottom. What do I do with 1/4? You're going to add it to both sides. X squared minus x plus 1/4. All right, so this process is seeming familiar, even though we're a little nervous now that we've got some fractions in the mix. Don't worry too much about it. All right, so what's going to go on the right side is I have to factor that. I want to figure out what that is now that it's a perfect square. I just completed the square. It's going to be x minus something squared. Because x times x is x squared again. I know it's a minus to get the middle term of -x. So what number squared gives you a 4th then? Oh wait, didn't I just do that? 1/2 squared is a 4th? So this actually just becomes x minus 1/2 squared. So don't be afraid of fractions. It's actually pretty easy because that b that I squared to get a 4th, that's now in this step, x minus the 1/2 squared is how we would rewrite that trinomial as a binomial squared. So what's the goal now? Get f of x alone again, get y by itself. And once y is by itself, we'll know where the vertex is, or that turning point of the parabola. So I'm going to subtract 1/4 to the other side. So that's now x minus 1/2 squared minus a 4th. And just careful about your algebra steps here. I would then, in the next case, multiply both sides by 4 to get rid of dividing by 4. So f of x plus 11 is equal to, if I distribute that 4 in, leave the 4 in front of the x minus 1/2 squared. Don't distribute it in. That would be breaking PEMDAS. Okay, leave it on the outside. 4 times a 4th is now -1 at the end. And then finally, last step, subtract the 11 over to get that f of x is equal to 4 times x minus 1/2 squared with a -12 on the outside. And we know a lot about this parabola right now. Based on our knowledge of function transformations, which wasn't too long ago, this graph is going to move to the right 1/2. It's going to have a vertical stretch of 4, and then eventually down 12 units. So what I'm going to have us do for part A, after all of that algebra, boy, I really got us started with maybe a tougher example here. The vertex is +1/2, comma, -12. Because of the horizontal and vertical shift that we know happens here, that's where the turning point will occur. Okay. So from there, what we can do is we have to then go ahead and find the roots. The roots come from setting this equal to 0. When I set this to 0, you have some options. Maybe it's factorable, but if not, you can complete the square or use quad formula. I'm going to be a little crafty and say, let's go to my vertex form equation that I had up here a second ago and just set that equal to 0. We've done a lot of the good work to start isolating x. It doesn't look that way. But if I start sliding some of these terms over to this side, right, like add the 12 back over there, now that we have it set to 0, and then divide the 4 out on both sides, we get x minus 1/2 squared is equal to 3. So if you take that vertex form and set it to 0, I happen to think that that can go pretty quickly to get x alone, because then if I square root both sides, x minus 1/2 equals plus or minus the square root of 3. And in the end, if you add the 1/2 over, these are the 2 roots. Okay, these are irrational values. They're going to be these ugly kind of looking decimals in the end. But through this process, we were able to find the vertex by completing the square. And then I wound up just taking that vertex form and setting it to 0, because it's typically not so bad from there to isolate x and find the roots if that's what we're looking for. Okay. Since we didn't use quadratic formula on that one, let's do quadratic formula on this next one. X squared plus 6x plus 10 equals 0. In fact, since quadratic formula, we've already done it once today, I'd encourage you to try it at this point. See if you can do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hit pause, try it. I'm going to go through my answers right now. All right. So for A, B, and C, A is 1, B is 6, C is 10. So x equals negative b, which is negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times A times C, 4 times 1 times 10, all over 2a. Okay. So I plugged in the information here. We get x equals negative 6 plus or minus the square root of what? Well, that's 36. Negative 4 times 1 times 10 is negative 40. 36 minus 40 is negative 4. Okay, so if you got to this stage and you had practiced this on your own, you're in a pretty good place. But we know the square root of negative 4 from Unit 5 not too long ago. I hope at least you remember it, right? Isn't the square root of negative 4 2i? So replace square root of negative 4 with 2i, and then just make sure you divide both of those by 2, not just your favorite. So the roots are negative 3 plus or minus I. And that's weird, because what are we finding? We're finding x-intercepts. We're finding where this crosses the x-axis. So I don't know. What is that going to look like if we have these imaginary, or these are called complex roots, right? Because it's an a plus bi form. Well, that's what tomorrow's lesson's all about. So I'm not going to give too much away yet, but when we get roots that look like this, we're going to know something about the graph pretty quickly. All right. Perhaps we'll do just one more here. For the last one, we'll do f of x equals 2x squared minus 12x plus 14. Okay. Let's find the vertex and let's find the roots. Okay, so if you're feeling pretty confident about this process, I know we've only done one together, but if you compare it to number 3 where we found the vertex and roots, then maybe you can try it on your own. You can hit pause and check back in with me. But otherwise, because we've done one, I might kind of go through this a little bit faster. I'm going to subtract the 14 over so that I can start getting ready to complete the square. So move the c over. Remember, leave this as f of x when you're finding the vertex. Don't plug in 0 yet. I forgot to mention y earlier. I'll mention it y in this one. Okay. Before you complete the square, you have to divide the 2 out because the lead coefficient has to be a 1 when you complete the square. The nice thing about dividing 2 in this one is that it does go in evenly to both, and it still leaves you with an even b value. And I like even b values because when I take b divided by 2 and square it, negative 6 divided by 2 squared is 9. So we're going to wind up adding 9 to both sides. So therefore, f of x minus 14 over 2 plus 9 equals, factor this, it's now a perfect square, x minus 3 squared. And then the whole goal is start moving terms back over to the other side, get f of x alone. So f of x minus 14 over 2, I'm going to subtract that 9 back over first. Here's what I was talking about a minute ago when I said don't plug in 0 for f of x. Because if you do, guess what? You're going to lose this 2, right? It's going to be a problem because 0 over 2 would be 0 then. So you have to be a little bit careful about that if you have to divide over a lead coefficient to complete the square, having a 0 there is going to be bad news. You're going to lose the 2 that you divided over most likely. All right, so multiply both sides by 2 at this point to get rid of that. So we get f of x minus 14 is equal to, distribute the 2 over here, 2 times x minus 3 squared minus 18. And finally, last step, add the 14 over to get f of x equals 2 times x minus 3 squared. If I add the 14, I get now a minus 4 over there. So if I think about where the vertex is for this particular parabola, we went to the right 3, stretched it by a scale factor of 2, and then down 4. So the horizontal and Vertical translating would bring me to the vertex at 3, -4. And you know what? I'll let you guys finish off with the roots there. Pick a method of your choice. Try and find those roots. If the original's factorable, go for it. If not, you can do CTS or quad formula. All right, a lot more to come with quadratics in this unit, but complete the square, finding roots, it's all very important stuff. Let me know if you have questions.